warahmatullahi wabarakatuh. Student,
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
morning student.
Morning, teacher.
Morning, Mister.
How are you today?
I'm fine, Mister.
I'm fine, and you?
How about you?
I'm fine, thanks you. Okay, before we start the lesson, let's say a prayer together. Miko, will you lead to prayer, please?
Yes, Mister. Let's begin to pray. Finish.
Okay. Let's check your attention, students. Who is not here yet?
Nothing,
Nothing, Mister.
Mister.
Okay. Does anyone still remember last week learning about SWOT? Does anyone still remember last week learning about SWOT?
The last in discussing about the nuclida, isotope, isobar, and isoton.
Okay, yes, that's right, Nita. Our last discussion was about nuclida, isotope, isobar, and isoton. Did you remember isotope?
I, Mister.
Yes, Miko.
Isotope is an element with the same number of proton or atomic number, different mass number.
Okay, good, Miko. Give applause for Miko.
Yes, Mister.
Okay, student. Today we are going to this discussion talk about deal with a relative mass of atom and molecule.
Yes, Mister.
Have all seen the PowerPoint?
Yes,
Yes,
Mister.
Mister.
Okay. Still passionate about learning today?
Yes, Mister.
Okay, must be attention, make your parents smile what your success, okay?
Okay, Mister.
Let's see the PowerPoint. Learning outcome or learning objective. Learners of are ability to calculate the relative atomic mass. Learns are able to calculate the relative molecular mass. Okay, today topic is reading 4 points. Miko, what is the relative atomic mass?
Okay, Mister. Relative atomic mass or ER is the relative atomic mass is the mass of an atomic determined by comparing it to the standard atomic mass. Relative atomic mass abbreviated to ER based on EUPAC or International Union of Pure and Applied Chemistry. Use and standard for determining the mass of relative atom is carbon atom. The atomic symbol is C.
Okay, good Miko. Thank you. Applause for Miko.
Thank you, Mister.
Relative atomic mass. Relative atomic mass, the mass of atom and determined by comparing it with the standard atom mass. Watch this video.
In the previous video, we have seen how atomic mass is measured. Let's understand atomic mass in detail. Before that, Can you tell me what exactly the concept of atomic number is? Can you define it once for me? Yes, it's simply the number of protons present inside the nucleus of an atom. Now, on similar lines, can you tell me what atomic mass could be? Yes, it simply means the mass of an atom. But how does it get determined? Imagine we have a bag which is made up of extremely thin material, so thin that it almost does not have any mass. Now we fill this bag with some stuff inside. If this bag is placed on a weighing scale, then can we say that the total mass of the bag will be the sum of the mass of all the objects inside it? Absolutely. Similarly, the mass of an atom can be calculated with the help of the subatomic particles in it. But we know that among all the subatomic particles, electrons have negligible mass. That is, they are considered to be almost weightless. So what are we left with? Yes, we have both protons and neutrons in the nucleus. And these two do have some amount of mass, is what we know. Now tell me one thing. Which among these two particles should be considered? Shall we consider only the mass of protons or only the neutrons? Or both together? Well, since both have a significant amount of mass, we will consider the mass of both together. Hence, the atomic mass is defined as the total number of protons and neutrons present inside the nucleus of the atom. It is also referred to as the mass number. Let us take a simple example. In case of a simple element like fluorine, we find that there are 9 protons and 10 neutrons in the nucleus. Wait a second. We have always come across cases where the atomic nucleus has an equal number of protons and neutrons. So how is it that the number of neutrons is more? Well, tell me, does the presence of additional neutrons really bother the atom? Does the charge of the atom increase or decrease? Absolutely not. That's because they're neutral. Then why should an extra neutron bother us? So coming back to the atomic mass of fluorine, we have 9 protons and 10 neutrons. That means the total would give us 90. So can we say that the atomic mass of fluorine is 19 units? That's right. Just like fluorine, even aluminium has an extra neutron compared to the number of protons. That is, in a single atom of aluminium, we have 13 protons and 14 neutrons. Summing up the two, we get 27 units, which is the atomic mass of aluminium. Now let's take another random example of chlorine. A chlorine atom has 17 protons and 18 neutrons. That means the atomic mass of chlorine will be 35 units, right? Absolutely. But wait a second. A few chlorine atoms that exist in nature exhibit a different form. Some of them have 17 protons and 20 neutrons. That gives us the atomic mass of chlorine as 37 units. So which one is the correct atomic mass? In case of chlorine, both the atomic masses are right. The atoms having 17 protons and 18 neutrons have an atomic mass as 35 units. On the other hand, chlorine atoms with 17 protons and 20 neutrons have an atomic mass of 37 units. But now the next question to pop up in our minds is, how can we have one element having 2 different kinds of atoms? And is this valid only for chlorine, or are there other elements also which exhibit this phenomenon? Let's find out more about this mysterious concept of isotopes in the next video.
Okay, students. Relative atomic mass. Then overseen the formulas of determinants the relative atomic mass atau or ER is a comparison of a break mass of an element with the 12 mass of one atom carbon 12. listen to one point. Look at the picture beside 1 minute. There are two isotopes of carbon in natural, namely the carbon-12 isotope and the carbon-13 isotope. Example, the mass of one atom of element X is, while the mass of one atom carbon-12 is grams. What is the relative atomic mass of element X? Answer. See the 4 point. Okay. Next, relative molecular mass. Relative molecular mass. Relative molecular mass is the ratio between the frag mass of one molecule to 1/412 of the mass of one carbon-12 atom. Now, Siti, what is the relative molecular mass? Siti,
I'm Mr.
what is the relative molecular mass?
Okay, relative molecular mass is the relation between the effect mass of one molecule to 1/12 of the mass of one carbon until 12 atom.
Okay, good, Siti. Thank you. So, relative molecular mass is the ratio between the effect mass of one molecule to 1/12 of the mass of one carbon-12 atom. Okay, all students, please read this 4 point. The relative molecular mass is a comparison between the effect mass of one molecule against 1 to 12 the mass of one atom, carbon 12 in one molecule, and sufficient consists of its consist atom. For example, one molecule CaOH2, there is one atom Ca, two atom O, and two atom A. Please see the video relative molecular mass. 7 minutes.
Now let's move on to something called the relative molecular mass. Most of the time we are working with molecules and compounds, so we have to learn how to add up all the relative atomic masses. So let's look at that now. The relative molecular mass is the average mass of one molecule compared to the mass of 1/12 of a carbon atom. So instead of the word atom, now we are looking at the molecule. But again, we are comparing everything to 1/12 of a carbon atom. The relative molecular mass has the symbol Mr, while the relative atomic mass has the symbol Ar. The relative molecular mass is taken by adding up all the Ar of the atoms, and it doesn't have a unit. Let's take a look at some examples. So nitrogen and 2. There are 2 nitrogen atoms in a molecule. So when we calculate the Mr, 14 is the relative atomic mass of nitrogen. For hydrogen chloride, you'll be 1 for hydrogen plus 35.5, giving us 36.5. Carbon dioxide, the relative atomic mass for carbon is 12, and we have 2 oxygen, so ethanol, we have 2 carbon, 5 hydrogen, 1 oxygen, 1 hydrogen, so you can see the link here, 2, 12, minus 1, 16, 1. So always show your working when you complete the mark. Now have a go at calculating the relative molecular mass of each of the samples. Pause the video now. Get the answers. You get all of them correct. Great, that's one. Now, one more term here, which is the relative formula mass. The relative molecular mass only applies to covalent substances because they exist as molecules. When we talk about ionic compounds, we can't use the word molecules anymore. So we have to use something called formula again. So the relative formula mass applies for ionic compounds only. But again, we compare this to carbon mass. The relative formula.
Okay, students, do you any question? Do you any question, student?
Nothing, Mister.
Okay.
Sir.
For example, reading this PowerPoint to break problem example to relative molecular atom. These are okay. Now anyone can collect today lessons.
I am Mr.
Okay, please Agus.
Relative atomic mass is the mass of an atom determined by comparing it with the started atomic mass, relative atomic mass, abbreviated as R.
Okay, good. Thank you, Agus. One more. One more. Siti. Or Nita.
Yes, Mister. I'm Mister.
Okay, please Nita.
Relative molecular mass is the ratio between the average mass of the molecule to 1/20 of the mass of one carbon 12 atom.
Okay, good, Nita. Please applause for Nita and Agus. Okay, today material concretes. Relative atomic mass is the mass of atom determined comparing it with the standard atomic mass. Relative atomic mass affect as R. ER. Relative molecular mass is the ratio between the effect mass of one molecule to 1/12 the mass of one carbon 12 atom. Okay, student. For homework, you do the exercise. I will send exercise in group class. Complete next week.
Yes, Mister. Thank you.
Okay. Because our time is up, before we finish the lesson, let's say frater together. Miko, will you let's prayer, please?
Yes, Mister.
Okay, Miko.
Before we finish our lesson, let's begin to pray. Finish.
Okay, thank you, Miko.
You are welcome, Mister.
I hope you enjoyed the lesson today. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Waalaikumsalam
Waalaikumsalam,
warahmatullahi wabarakatuh. Morning, sir.
Mister.
Okay.
Thank you, Mister.